Welcome everyone. We are discussing fundamental results of derivative. In previous video, I have already discussed some fundamental results. Sum of derivatives, number 2 difference of derivative, derivative of constant function, and derivative of c into fx. And number 5, product rule of derivative. Product rule of derivative. So, if fx and gx, what is the product rule? If fx and gx are two differentiable functions of x, then ddx of fx into gx. So fx unchanged, ddx of gx plus gx unchanged, ddx of fx. So this is plus. So that's why we can interchange it. First function unchanged, derivative of the second, plus second function unchanged, derivative of the first. If there are two functions, we can perform product rule of derivative. So application, ddx of, but what is our main aim? To remember all the 10 standard result. ddx of 2 to the power 2x into log 3x base e. So this is one function, this one is another function. So 2 to the power 2x unchanged, ddx of log 3x plus log 3x unchanged, ddx of 2 to the power 2x. Now use your fundamental results. So 2 to the power 2x, derivative of log 3x is 1 by x. You can write it directly, 1 by 3x into 3, and log 3x, this is 2 to the power 2x into log 2, obviously base is e into coefficient of x. So 2 to the power 2x, this is common, 1 by x, 2 log e base 2 into log 3x. So product of two functions. So main aim is you have to remember the formula. Next, y equals to e to the power x plus e to the power 3x by e to the power x plus e to the power minus x into x. Now, look, this is given in ratio form. So our main aim is to simplify it. So look, e to the power x and e to the power 3x. So e to the power x is common. 1 plus e to the power 2x. So e to the power x, 1 by e to the power x into x. Next, if we simplify, x unchanged, e to the power x, 1 plus e to the power 2x. So look, e to the power 2x plus 1 by e to the power x. So it will be at the numerator. So these and these cancel. So we get x into e to the power 2x, e to the power x into e to the power x. So our main aim is to express it in terms of simple one. So now use product rule. dy by dx, x unchanged, ddx of e to the power 2x, e to the power 2x unchanged, ddx of x. So perform derivative, x into e to the power 2x into 2, e to the power 2x into 1. So e to the power 2x common, 2x plus 1. So listen again. Try to simplify y if possible. So it is simplified. Use product rule. Apply basic derivatives. Now, if there are three functions, more than two, so if fx, put a rule for three functions. If fx, gx and hx are three differentiable function of x, then dy dx of fx, gx, hx equals to. So considering these fx into gx as single and hx, we can prove gx if fx, gx and hx are three differentiable function of x, then ddx of fx, gx, hx. So derivative of fx, two functions unchanged. Derivative of gx, other two unchanged. Derivative of hx, other two unchanged. So for three functions. And you learn later. So you can avoid this product rule if you use logarithmic derivative. But up to three functions, you can use product rule. So d dx of application, d by dx of e to the power x log root x into tan x degree. Tan x degree. Now we know derivative of e to the power x, derivative of log x, but this is not linear. But you can simplify it. Log root x equals to log x to the power half equals to half log x. So log root x, this is not linear, but we can simplify it using property of log. So what is the simplified form? dy dx of e to the power x half log x tan x degree. So half is outside, d dx of e to the power x log x tan x degree. So c into fx, c outside. Then formula. So log x into tan x degree unchanged, d dx of e to the power x. E to the power x into tan x degree unchanged d dx of log x plus e to the power x into log x unchanged d dx of tan x degree. Now use basic derivatives, formula of basic derivatives. So half unchanged log x, obviously base is e, tan x degree into e to the power x. E to the power x, tan x degree unchanged, derivative of log x is 1 by x. Then e to the power x, log x unchanged, pi by 180 sec square x degree. Derivative of tan x degree sec square x degree to be noted multiplied by pi by 180. Now taking e to the power x common. So e to the power x common by 2 unchanged. So this one and this one. This will be common. So you get answer in this form. So up to 3 we can take product rule. But if it is more than 3 or 3, we use logarithmic derivative. You learn later. Now, fundamental result. Six. If fx and gx are two differentiable function of x, then d dx of fx by gx equals to. So this is called division rule or quotient rule. It is given in division form. Gx whole square, denominator unchanged. Denominator unchanged, derivative of numerator. Numerator unchanged, derivative of denominator. So this is called division rule. Division rule or quotient rule. Division rule or quotient rule. If fx and gx are two differentiable functions of x, then d dx of fx by gx, gx unchanged, derivative of numerator, minus fx unchanged, derivative of denominator by denominator whole square. Mind it, here it is negative, so you cannot interchange the order. In product rule, you can interchange it, but here denominator unchanged. So y equals to e to the power minus x by tan x by 2. So there are two functions, e to the power minus x and tan x by 2. So we can write it also cot x by 2 and you can use quotient rule, product rule. But if it is in this form, so look, dy dx equals to d dx of derivative with respect to x, tan x by 2 e to the power minus x. So denominator whole square, tan x by 2 whole square. Tan x by 2 unchanged, d dx of e to the power minus x. E to the power minus x unchanged, d dx of tan x by 2. Use formula. Then put the basic results. So tan square x by 2. Tan x by 2 into e to the power minus x into minus 1. Mind it, e to the power minus x and coefficient of x. E to the power minus x. Sec square x by 2 into. So take e to the power minus x common and write the result. So this is quotient rule. So first function unchanged, denominator unchanged, derivative of numerator minus numerator unchanged, derivative of the denominator. Now I consider one more most important problem. So sin x minus x cos x, x sin x plus cos x. So look, we cannot simplify it. So you have to use quotient rule. So derivative of y is dy dx. X sin x plus cos x whole square. X sin x plus cos x unchanged. D dx of numerator sin x minus x cos x minus sin x minus x cos x unchanged, derivative of denominator. So up to this is very simple. Now you perform derivative. So x sin x plus cos x whole square. X sin x plus cos x, this one is unchanged. Now derivative of sin x is cos x. And this x cos x, derivative of x cos x, you have to use product rule. Mind it, x into minus sin x plus x unchanged, derivative of cos x is minus sin x, cos x into 1. So this is derivative of this one. Mind it, x cos x, here product rule is used. Minus sin x minus x cos x unchanged, x sin x, product rule, x into cos x plus sin x. And what is derivative of cos x? Minus sin x. So this should be noted. Here x cos x, it is product, here also product. Now it is plus cos x and it is minus cos x cancel. And sin x cancel. So finally what we are getting? X sin x plus cos x whole square. X sin x plus cos x and into x sin x, minus minus plus sin x minus x cos x into x cos x. So this is our result. But we try to simplify it using trigonometry. Look, x square sin square x, x sin x cos x minus x cos x into sin x cos x sin x plus minus minus plus x square cos square x, x sin x plus cos x whole square. So this one cancel. So finally what we are getting, you look, x square common, sin square x plus cos square x. So this is 1 and denominator unchanged. So we are getting simplified value x square by this. So please note this problem. Here you have to use product rule, then one term will be cancelled out. So this is most important problem. So main aim is to, before differentiation, you must simplify if possible. So today, through this video, we have discussed fundamental results of derivatives and solved some important but simple problems. So thank you for today.